Okay. Okay, let's start the class. So today, as I have already told you in the previous class, that we have some numerical problem to solve after discussing the activity of group file. So this is one kind of problem regarding group of files. Okay. So all of you can get the problem statement now. This is one kind of problem regarding group of files, activity of group of files. Okay. There, what is given? What are the informations given in this problem? That is, first 12 numbers of files are provided. Diameter of each of the files is 500 millimeter. That means 0.5 meter. Embedded length, actually I have written here depth, but as I have discussed in the class, as the length of the file, embedded depth and embedded length is same. Okay, so in any problem, embedded depth or installed depth is given. That is the total length of file that is inserted into the file. Okay, that length is given as 8 meter. This information is not very much required for this problem. Okay, that means obviously files are used to support something, some base of such structure. Here, all these files, 12 numbers of files are provided to support the platform of a jetty. Jetty means where launches and small ships are anchored. Okay, so that jetty is supported by these 12 numbers of files. Okay. The files are arranged in 3 identical rows. That means each row will have 3 rows, 12 files. So each row will have 4 numbers of files. Okay. Spaced at 1.75 meter center to center distance. Okay. The subsoil characteristics is given here. What you can conclude after this subsoil condition? After this subsoil condition, that means gamma saturated is given, saturated granular is given, phi is given, C is given, alpha is also given. So what you can conclude about the soil after these characteristics? Anyone? Yes? Cohesive soil, because phi is given as 0 and there is a value of C. What is alpha? Yes, addition factor. Good. So all of you can remember the discussions of previous classes. I am supporting this. Okay. Now coming to the solution of this problem. Now, if you can remember the discussions of previous classes, the activity of group file is classified into 2 categories or 2 characteristics. Actually, the group file activity, the bearing capacity or the ultimate bearing capacity of group file can be calculated or can be determined by 2 features of file or 2 features of failure of file. I should say, one is, all of you forgotten all those things. One is the block failure and another is the individual failure of file. In the last class we have discussed that part. Okay. Block failure means all the file will act as a single file, as a rectangular or square shape of file. And another features of failure will be individual file failure. Okay. So the thing is that for this kind of problem, if the feature of the failure is not given to consider, that means in this problem there is no information about the failure of the file. Is there anything given regarding the failure of file? Is that block failure or individual failure of file? Not given now. In that case, we have to consider both of the failure condition or failure features, okay, and determine the alternate load bearing capacity, or in this case safe axial load bearing capacity you have to calculate. So load bearing capacity you have to calculate considering both the failure characteristics, that is block failure and individual failure, okay. And as this is given as safe means what is safe? Factor, yes. Safe bearing capacity or safe load bearing capacity means factor. That means ultimate load bearing capacity divided by factor of safety, and in this case of foundation we can use the factor of safety of 3. Okay, so that is safe load bearing capacity. Now this is the factor safe load bearing capacity, but as I have told you that you have to consider both the failure characteristics, block failure and individual failure. So after determining the load bearing capacity considering two failure characteristics, you have to take the smaller one. That means we are considering the safer side. That means which one is the smaller bearing capacity? That smaller means we are in the safe side. Smaller load bearing capacity means we are in the safe side, and greater load bearing capacity means we are in the post condition. Okay, anytime that pipe can be filled. After that, greater load bearing capacity, if we consider greater load bearing capacity after that calculation. Okay, so this is the problem. So my question is that all of you can solve this problem. Basic concept is target bearing capacity theory, and point bearing capacity is, what is the point bearing capacity of pipe? Can you check your copy? I think all of those formulas and equations are written there. You can see that load bearing capacity by Target bearing capacity theorem is CNC plus QNQ plus half B gamma N gamma, that is for shallow foundation. And in case of pipe, the first part of point bearing capacity, point bearing means that load which may be carried by the tip, base tip of the pipe. If this is the pipe, this is the tip. So by this tip, the load that can be carried, that is the tip bearing capacity of pipe or point bearing capacity of pipe, and that is coming from the target bearing capacity theorem. That is nothing but CNC plus Q1Q plus half B gamma N gamma. All of you have forgotten all those things, no? And what about the second part? Second part is the shaft. That means by the skin of the pipe, shaft of the pipe, this surface, that load that can be carried by the skin of the pipe, this curved surface of the pipe, and that is P. Can you check from your copy? नहीं तो जल्दी से there are two conditions, one is called cohesive soil and another is called cohesionless soil. So for cohesionless soil, the concept is coming from the lateral pressure. Okay, K tan delta, then already I have provided you the notes all the things are given in the that what is that thing? Canvas. Yes. All the things are all the notes and documents and materials are given in the canvas. All the notes I think I have provided you. So nothing is with you and in your mind, in your brain. Yes. কি এটা কি করব তো ক্যানভাস ওকে I think note 13 or 14. Let's open. Oh no, not 13 or 14. That before that. Oh, this is group file. Okay, that. For cohesive soil, it is coming from the concept of lateral up pressure, and for cohesive soil, the concept is coming from the adhesion force. Adhesion force between the surface, top surface of the pile and the adjacent soil layers. Okay. Pages. এগুলো বুঝতে পারলে কোনটা? খুলে দেখি। Okay, so here what is given? 12 piles, 12 numbers of piles. In 3 numbers of rows. Standard distance of each pile is given as how much? 1.75 meters. Okay, so this is 1.75 meters. This is also 1.75 meters. No, not this one. We have to open the notes regarding the ultimate load bearing capacity of single pipe or new is QU, the formula regarding QU. Yes, this one. Obviously. Yes, QF plus QB. What is QF and what is QB? Yes, but this is for cohesive soil. For cohesive soil, this alpha is for cohesive soil. This alpha term is coming in the case of cohesive soil because this is the adhesive coefficient of adhesion force. So in that case, you have to go for the alternate formula for cohesive soil. Okay. So considering individual pipe failure, the ultimate load bearing capacity for a single pipe, okay, not the group action.